Welcome to class today, pre-cal scholars. Today is Thursday. That is, if you're on top of the videos. I hope you're not listening to this a week or two late. But anyways, in the future that is. But welcome to class. Today's Thursday, October 3rd. Welcome to your best hour of the day, I'm sure. Definitely sarcasm intended. I usually have all the announcements typed and all that. I want to really jump into the notes fast today to give you more time to work on your review sheet. Now, it's not bigger than usual. It's about the same size as always, 43 problems. That's about normal. But I really want to get this this lesson knocked out here and allow you to start working on your review sheet if you so choose to do that. Okay, so instead of typing the announcements, I'm just going to whip through them. You know you got a test Friday. I've been announcing it now all week. You know that you'll get a review sheet today to work on. You know it's due Monday if you want the 5 bonus points. You know to call me if you're not going to come Monday, so I know that. When you show up Monday, you're welcome to ask questions on the review sheet, take the test, ask questions on other quizzes and tests. All of that is up to you. However, just be organized. Make sure your integrity sheets are caught up, and don't get behind in the videos. That's the killer. And you know, I want to say this real quick. If you were to go to college, you could not just decide which days you want to school. Actually, to class. Actually, that's not true. You could. There are plenty of colleges out there that you pay your money, and if you come to class, fine. If you don't, fine. But you know, it's not the best way to get an education, and definitely in high school where you guys are, you got to be in class. Okay, so please don't get behind the videos, guys. Please work hard and call me or email me if you have any questions at all. Okay, so that's pretty much the announcements in a nutshell. I'm trying to turn the Mimeopad on right now. There we go. All right. Definitely don't want that thing to quit working. We're looking at a heading today, or a topic, whatever, called half-angle identities. Please write that in your notes. Right here, I'm moving it around for you right here. Half-angle identities. The lesson number is 6-2, and the date today is 10-03-13. All right, so man, I mean, Thanksgiving's around the corner, and the 9 weeks is almost over, and man, Christmas before you know it. So time goes by quickly. 2014 is right around the corner. But anyways, half-angle identities, lesson 6-2, 10-3-13. Now, you should always have your notebook, your books, your calculators, all of those things ready. And let's go ahead and jump into what the half-angle identities are like. Now, again, I'm trying to go fast today, so I'm not going to sit here and review like I did yesterday. We've learned basic identities, Pythagorean identities, double-angle identities, sum and difference identities, etc., etc. Okay? I'm just going to jump right into today's notes to save time. Here are the half-angle identities. They're right here in front of you. Notice they're on page 552. So if you would like to turn to page, excuse me for stuttering, if you would like to turn to page 552, feel free to do that. You will find right there on that page these trig identities. And they're called half-angle identities for this reason. Please watch this carefully. If I wanted to find, I don't know, let's just say the sine of 120, okay? No, that's not true. Hold on. If I wanted to find the sine of 15 degrees, okay? The sine of 15 degrees. Now, you can take notes on this or you can just watch. That's up to you. But do you realize how you could rewrite the sine of 15 like this? Could you not do this? Could you not put 30 over 2? Sure you could. What's 30 divided by 2? 15. I didn't change anything. But you know what I did do? Look at this identity right here. Do you see how sine of x over 2, in this case 30, would be your x, 30 over 2. Do you see what I've done here? Now instead of finding the sine of 15, which by the way, 15 is not one of my special angles, so it would be very hard to find the sine of 15 using exact numbers unless I knew this trick right here, which I'm doing right now, and here it is. I can rewrite 15 as 30 divided by 2. Now, how does that help? I'm glad you asked. Do you see this 30 right here? Isn't that x? Well, sine of 30 over 2 equals this, only now for cosine of x, you would have cosine of 30. Because, again, don't forget, what's on top of your fraction over here? A 30. So 30 is your x. So when you come over here, you have 1 minus cosine 30 over 2. So this whole expression here equals all of this over here. So instead of finding the sine of 15, you could find the sine of 15 over 2. And if you want to find the sine of 30, I said 15 over 2, sorry. Instead of finding the sine of 15, you could find the sine of 30 over 2. And if you're going to find the sine of 30 over 2, you could use this right here, all right? So this, this is pretty helpful, like most of the trig identities, although you might argue with me, you probably find them pretty annoying, but they're pretty helpful, and they're well thought out, and they're pretty cool stuff. Now, there is something I want to show you. Notice tangent of x over 2, it equals 3 different expressions. You could use this one, or you could use this one, or you could use this one. So do notice that tangent of x over 2 has 3 different identities you can use. Sine of x over 2 equals this, and cosine of x over 2 equals this right here. Now, listen, we must talk about these plus minus signs. How do you know when to use plus or positive, and how do you know when to use negative? Well, I'm glad you asked. Here's how you know. Would you please listen carefully? You take this entire x over 2, now listen, and whatever quadrant that falls in, you use that sign. So if you're looking at sine of this angle, and sine is in second quadrant, that's positive. If it's in the third quadrant, sine's negative. If you're in the fourth quadrant, sine's negative. If you're in the first quadrant, sine's positive. Now, you say, well, Mr. Earhart, what do you mean by take this whole angle here, x over 2? Well, I'll show you. Remember the previous example that I showed you when you had the sine of 30 over 2? Like this, okay? Well, 30 divided by 2 is 15, correct? 30 divided by 2 is 15, and 15 lies in the first quadrant. You see what a lot of students want to do, and actually my degree sign should be here on the inside. But anyways, here's what a lot of students want to do. They want to look at what your x is right here, and they're like, oh, okay, man, it's 30, so I'm in that quadrant. Now, in this case, 30 and 15 are both in the first quadrant, so it doesn't matter. But do not use that top number. That will sometimes put you in the wrong quadrant. You take this entire expression, type it into your calculator, see what you get out, and whatever quadrant you're in, that's the sign you use, depending upon whether you're using sine, cosine, or tangent. And we're going to practice that, but I do want you to realize here, you have got to be very careful with which sign you use here. You just don't kind of close your eyes and point and hope that you hit the right one. There is a way to do that, okay? All right, let's continue on. Now, by the way, this needs to be on your trig identity sheet. I hope you guys are being good, thorough students, organized, neat. I hope that you've got your trig identity sheet all caught up. So now go ahead and add this to your trig identity sheet right here. And remember, on any test or quiz, you are not only more than welcome to use your trig identity sheet, you're encouraged to use your trig identity sheet. So you're more than welcome to put this on your trig identity sheet. Let's continue on. I would like to look at 1, 2, 3, 4 problems and then give the review sheet. Okay, I'm trying to go fast today. I would like us to find the tangent of pi over 8. Now you understand, students, when we're going to start taking these numbers and using these half angle identities right here with fractions, I'm just telling you right now, the last thing I want is a fraction within a fraction and radians, so I am going to convert this over to degrees. So, call me a wimp if you want to, but I'm really not looking forward to having any type of fractions. So the first thing I'm going to do is off to the side here, if you want to go ahead and take notes, I'm going to take pi over 8 and multiply it times 180 over pi, all right? And of course your pi's cancel. And then what goes into, I know 4, let's say maybe 8, let's see. 45 and 2. 4 goes into both of these, so 4 goes into 8 2 times. And 4 goes into this 45 times. Of course, we have a 1 here and a 1 here, so 1 times 45 is 45, and 2 times 1 is 2. So now divide that out, and you get 22.5. 45 divided by 2 is 22.5. So instead of taking the tangent of pi over 8, I am going to take the tangent of 22.5. Now, students, remember, we want to use exact numbers. So we're somehow going to have to get this thing transferred over to where it either is 30 degrees, 45 degrees, or 60 degrees. Remember, those are our special angles, our special triangles that we know. So I'm sitting here working hard, and boy, booyah, I think I see it right here. Remember over here, 45 over 2 was 22.5. Remember that? So instead of using 22.5 degrees, now let's stop right now. I hope y'all remember how to convert radians over 2 degrees. You always take radians and multiply it by 180 over pi. Having done that, we got 22.5. But I somehow want to rewrite this so that I have a 2 in the denominator and a number up top that is one of my special angles. And I think I've got it right here. You see, instead of taking the tangent of 22.5, I'm going to take the tangent of 45 over 2. Is that okay with everybody? Should be. 45 over 2. Now, it looks like I'm going to be dealing with 45 degrees, so I'm going to go ahead and set up a triangle down here to help me. I think that'd be a wise thing to do. And I'm going to go ahead and draw my special triangle. That's a right angle right there, even though it doesn't look like it. And this is a very sick triangle. Looks pretty bad. Anyways, 45 degrees. This would be a 1, this would be a 1, and this would be a square root of 2. Some of you might not yet have these memorized, your special triangles. That's really, really not good. Okay, I hope you're not there. Anyways, tangent of 45 over 2 equals, now remember, this is your x right here. 45 is your x, okay? So let's come over here. And you can use any of these. Now, why in the world someone would want a square root when they don't have to, I don't know. I'm not going to use that. I'm going to use one of these. I'm going to use this one right here. Sine x over 1 plus cosine. So, sine x over 1 plus cosine x. Now, 45 degrees, of course, is my x. So tangent of 45 over 2 equals this. So now I'm simply going to say the sine of 45 degrees over 1 plus cosine of 45 degrees. Now, let's be very careful here. Let's take our time and work this out. Let's go really slow. The sine of 45, well, opposite over hypotenuse. 1 over square root of 2, which of course when you rationalize would be square root of 2 over 2. That's the numerator. Now let's go to the denominator. We have 1 plus the cosine of 45. Now the cosine of 45 would be adjacent over hypotenuse. Adjacent over hypotenuse, which is 1 over square root of 2, which of course when you rationalize is square root of 2 over 2. Now I'm going to take my time and we're going to really do this right. So now all that I have to do is a bunch of simplification, okay? So I'm going to grab this big kind of mess here, and now let's see if we can't do some work on it, okay? First of all, let's go down here to the denominator, okay? Let's just forget the numerator. See this numerator? Just leave it alone. Let's work with the denominator. You see this 1 right here? You see how I have a denominator of 2? Let's go ahead and write 1 as 2 over 2, because I want to put these two fractions together. I want to combine these two, okay, students? So, I mean, why'd you put 2 over 2? Put 3 over 3 or 10 over 10. I chose 2 because what is my denominator right here? My denominator is 2, so if I have 2 over 2, now I've got a common denominator. Again, we're not worried about the numerator. Forget about the numerator. Now, let's go ahead and combine these two fractions. So I have 2 plus square root of 2. They're unlike terms, so do not combine them. Just write them side by side. So look at that. So I have 2 plus square root of 2 all over 2, and up top I have square root of 2 over 2. Isn't this fun? Not really. I know it's a pain. Now I have one fraction up top, and even though it's a big fraction, I have one fraction in the bottom. So now I have square root of 2 over 2 divided by 2 plus square root of 2 over 2. Now look, I've got to take the second fraction and flip it and multiply. So there we go. And I get to use my cool little toy here. It didn't work, did it? Let's try the cool little toy again. Not happening today. That's all right. We can at least yank this out of the way and bring it down here. And there's more than one way to skin a cat. Oh, look at that. All right. So there. with much pain, I have finally flipped my fraction. Now, before we multiply, look at this. 2 cancels with the 2. And here's what some of you want to do. And oh, I want to scream. You want to cross this off and cross that off. No, don't do that, okay? Can't do that. Look, men, we have 2 terms down here. Now, if this was one term, if it was 2 square root of 2 and they were multiplying, then sure, cross them off. I have no problem with that. But you cannot just cross things off like that when you have 2 terms down here. So you cannot cross cancel. So let's go ahead and multiply. Square root of 2 times 1 would be square root of 2. And 1 times all of this would be 2 plus square root of 2. Now, I did not write the mathematical book of the universe, okay? And I'm not the one that makes all these rules. But we do not want this denominator to have a square root. So we have to rationalize. So we're going to remember, I went over this the other day with you guys. Whatever this middle sign is here, you always change that sign. If it's negative, you use a positive. If it's a positive, you use a negative. So 2 minus the square root of 2 over 2 minus the square root of 2. So whatever this sign is right here, I change it, and I write the same thing over the top and bottom, and now I multiply. Now watch what happens when I multiply. Square root of 2 times 2. Well, that would give me 2 square root of 2. And then square root of 2 times negative square root of 2. Well, that would give me a negative 2. Remember, square root of 2 times square root of 2 is just 2. Now, let's come down here to the bottom. I'm going to take this 2 times 2 and this 2 times negative square root of 2. So, here we go. 2 times 2 would be positive 4, and 2 times negative square root of 2 would be negative 2 square root of 2. Now I'm going to take this square root of 2 and multiply it times a 2 and multiply it times the square root of 2. So here we go. Square root of 2 times 2 would be a positive 2 square root of 2, and square root of 2 times a negative square root of 2 would be a negative 2. Now, do you see what has happened here other than complete boredom and probably putting you to sleep? Look at the denominator. Do you see how your square roots are going to cancel? I mean, look, we have a negative 2 square root of 2 and a positive 2 square root of 2. So these cancel out. They're gone. And then you've got 4 minus 2. So your whole denominator just becomes a 2. Up top, you have 2 square root of 2 minus 2. Now, if you want to reduce this by 2, you can, because the 2 will go into all of your terms. And as long as you're reducing outside numbers with outside numbers, not this inside number right here, you want to leave that alone, okay? Well, 2 goes into 2 goes into 2, so this 2 becomes a 1. 2 becomes a 1. 2 becomes a 1. And I'm left with 1 square root of 2 minus 1 all over 1. You leave this inside number alone. You don't mess with that, okay? Now, anything over 1 is just itself, and you really don't have to put this 1 in front if you don't want to. So really what you have is simply square root of 2 minus 1. Square root of 2 minus 1 all over 1, which of course is just square root of 2. All right, so there we go. Not an easy problem, but it's one of the 4. We're 25% of the way done. We're working on it. But what we did is we took tangent of pi over 8, which is tangent of 22 over 5. By the way, you could have solved this with a calculator. Typed it in, got out some decimal, but look at the directions. The directions said use exact numbers. So we knew somehow we had to work into this problem either 45 degrees, 30 degrees, 60 degrees, something with an angle that we're aware of, okay, or that we're familiar with. Okay, now let's try to find the cosine of 75 degrees using exact numbers. Now please watch what I'm going to do, okay? Be very, very careful here. First of all, I am going to rack my brain and think, how in the world can I use cosine of something over 2 in which I get out 30 or 45 or 60? Well, can I show you something real quick, please? Watch this. I'm going to go ahead and put 150 over 2. Now, I know what you're thinking. I think I know what you're thinking. You're thinking, Mr. Earhart, 150 is my x, and that's not a special angle. You're right, it's not. But if you'll trust me and watch what happens, I think in the end you're going to see something. Whoa, I just threw my calculator. All right, I think in the end you're going to see something that's really, really cool, as is all math really, really cool. Oh, the phone's ringing. I'm going to pause this video. So hopefully you trust me, and hopefully you'll just kind of follow along here. Now, the cosine of 150 over 2. Well, here we go. Let's look at our trig identities. That would be plus minus 1 plus cosine over 2. So here we go. Plus minus 1 plus cosine x all over 2. Let me check that again. I don't have these memorized. I used to. I really did in college and in college, but not anymore. All right, let's see here. 1 plus, there we go. Okay, good. Now, please watch what happens next. This is very interesting, okay? Next, I have plus minus. Let's stop right now with the plus minus, shall we? Yes, we shall. Remember how I told you how you know which sign to use? I taught you at the beginning of this video, you don't look at the top number. Guys, if you looked at that top number, you would think that it would be in the second quadrant over here, okay? You do not look at the top number. You look at what this whole fraction is, and 150 divided by 2 is 75. So where is 75? Quadrant 1. And what is cosine in the first quadrant? Well, everything is positive. So right off the bat, let's go ahead and get rid of this plus minus right now. Now we know we're going to use the positive sign because we're in quadrant 1. So here we go. So now I have 1 plus cosine of x. Now what's cosine of x? 150 all over 2. Oh, snap. I mean, I wish I could find the cosine of 150. It's not one of my special angles. Hey, maybe it is. Hold on a second. Remember about, I don't know, 3 or 4 weeks ago, if I asked you to find the cosine of 150, you did this right here. Do you remember what you did? You found a reference angle, you went 150 degrees, and then you drew your triangle. Remember, it's like a bow tie. You draw it onto the x-axis, okay? It's always like a bow tie, okay? Your triangle should always be on the x-axis. So, if I asked you to find the cosine of 150, you would rotate 150 degrees and find the reference angle. Of course, if I would have gone all the way through, that's 180. So if I only went to 150, that means I have 30 degrees left. Oh. So in other words, I can find the cosine of 150 because the cosine of 150 is the same thing as the cosine of 30 as long as I remember my signs over here are positive, negative, negative. So I can find the cosine of 30 instead of the cosine of 150 as long as I remember that cosine is negative in the second quadrant. So here we go. So I have negative, well, let's just do this. I have cosine of 30 degrees, and that would equal negative. Now what is the cosine of 30 degrees? Well, let's find out, shall we? Here's that triangle you're supposed to have memorized. 30 degrees, this would be a 2, this would be a 1, this would be square root of 3. So the cosine of 30 would be adjacent over hypotenuse, square root of 3 over 2. Of course, there would be a negative sign because in the second quadrant, cosine is negative. So negative square root of 3 over 2. Now, a lot of you are saying, Mr. Earhart, you're telling me we were in the first quadrant earlier. Hold on. Let's back up. Yes, when I told you to find out what sign we were going to use, I taught you to look at this fraction and type that whole fraction into your calculator, and whatever quadrant you were in when you typed this fraction in, that would show you whether to use a positive or a negative. We did that, and we found out we were going to use a positive. But now I'm inside the radical, and now I'm trying to find the cosine of 150. That's something entirely different. So now I'm inside the second quadrant trying to find the cosine of 150. And the cosine of 150 is the same thing as the cosine of 30 as long as I use negative square root of 3 over 2. So now here's what I have. I have a mess, basically. I have this big square root, then I have 1 plus, and then of course cosine of 150 is negative square root of 3 over 2. So plus minus would just be 1 minus square root of 3 over 2 all over 2. Now, students, listen to me, okay? I'm not sure how strict the book is going to be and what they would want you to do in this situation. If I had, I guess technically what I should do, to be honest, I'm kind of scared to do this, and maybe I should have worked this out ahead of time, although I totally know what I'm doing. I want you to have confidence in me, but I just hate to spend a lot of time on this and then realize in the end it really didn't matter. I guess technically we should work under the radical real quick here, and if you'll look at just the numerator, you have a 1 right here. I would put 2 over 2 for 1 minus square root of 3 over 2. Do you see how I did that? See this 1 right here? I would make that 1 2 over 2. I really would, because my denominator is 2. And now you would have 2 minus square root of 3. 2 minus square root of 3. So 2 minus square root of 3 all over 2 all over 2. Do you see how I did that? I put these two fractions together. 2 minus square root of 3 all over 2. 2 minus square root of 3 all over 2. And then all over 2. And now what I can do next is I can take this inside here, and I can actually say 2 minus square root of 3 all over 2 divided by 2 divided by 2 over 1. And of course, really, I'm going to flip this and multiply. So really, it's 1 over 2. And so what I would end up with is the square root of 2 minus square root of 3 times 1 is 2 minus square root of 3 all over, and 2 times 2 is 4. Now please don't make the mistake of canceling this 2 and 4 and reducing. What's in front of this radical, even though you can't see it? A 1. And you can't reduce a 1 by 4. So if you can't reduce all of the terms by 2, then don't reduce, okay? And there you go, you did it. That's it? Yeah, that's it. So what you did, contain your excitement, is you found the cosine of 75, and you could have typed into your calculator. In fact, I'm going to do that real quick. Cosine of 75 gives you 0.2588. But it said, the directions said to use exact numbers, so I had to use exact numbers. And by the way, when I typed in cosine of 75, make sure you're in degrees. You get 0.2588. That's supposed to be the decimal answer. Guess what I did? Now I jumped ahead, and I typed this into my calculator, the answer right here. Yeah, guess what I got out when I typed that in my calculator? 0.2588, the exact same thing. So what you did is you just found the cosine of 75 degrees, only you did it using exact numbers. To me, that's pretty cool. Okay, now we want to get into simplifying. So I want you to take this fraction here, and I want you to simplify it so that you derive or come up with tangent of 2x. Not an easy task, okay? So let's be really, really careful here, and let's see if we can't, do this, hopefully not too difficultly. Now, if there is such a word. Now, here we go. So I've got the sine of x. Remember, there's no steps to do here. I can't really give you step by step. That's not possible. But what I can do is give you little thoughts. Like, for example, as soon as I see that I've got a fraction within a fraction, I'm like, dude, no, we don't want that. So I'm thinking, can I multiply the top and the bottom by something? I think I can. Watch this. This is kind of being creative, but we can do this. You can multiply a fraction by anything as long as you do it to the top and the bottom. So sine x cosine x times 2 would simply be 2 sine x cosine x. Mr. Earhart, why are you doing this? I think you're going crazy on us. No, not at all. Now, 2 times 1/2 cosine 2x, well, 2 times 1/2 is just 1. So you get 1 cosine 2x. Notice you do not multiply the 2 times the x or times the x. Do not do that. You do not multiply this 2 times the 2x. No, you multiply the 2 times the coefficient out front, okay? So I multiply the 2 by the out front, 2 sine x cosine x, and then 2 times 1/2 would give me 1. Now do you see why I did that? Now I no longer have a fraction here in the bottom of my fraction here, okay? I do not have a fraction within a fraction. And by the way, I really don't even want that 1 there, to be honest with you. I really don't need that 1 cosine 2x. So I'm just going to come down here, drag it, get rid of it, and moving on. Now, you should have your trig identity sheet in front of you. You should go to bed every night with this and just sleep there. That's your best thing in the world. I'm kidding, of course, but you should have your trig identity sheet with you when you come to class every day. So, if you'll look, please, at your double angle identity section, you should see this right here. Look at your double angle identity section. You should see sine of 2x equals 2 sine x cosine x. Do you see that? If you don't have your trig identity sheet, then let me give you a page number. Turn in your books to page 551, and you'll see it right there at the top, page 551. So do you see this numerator, 2 sine x cosine x? 2 sine x cosine x. I can substitute in for this sine of 2x. Now look what I have. I have sine of 2x over cosine of 2x. Is that a big deal? Yeah, it's a big deal. If you'll look at your basic trig identities, they say tangent equals sine over cosine. So sine of 2x over cosine of 2x would equal tangent. Now you can't just change the angle, it's still got to stay 2x. Sine 2x over cosine 2x is tangent 2x. All right? And that was our goal right there. Sweet. One problem left. Simplify this so that you come down to a 1. You derive with the number, come up with the number 1, excuse me. So this will be a little interesting. Let's see if we can't, try something here. So here we go. Now the first thing I'd like to show you is we do have a half angle identity, x over 2, but we have sine squared. So I think it would behoove us greatly, I think it would be wise, it would help us to write 2 and then sine of x over 2 and then write it again, sine of x over 2. I think that'd be really helpful, and then put plus cosine x. And you see why I did that? Whenever it says sine squared x over 2, that means you have sine of x over 2, sine of x over 2 written twice. Now that we've done that, does everybody, let's go back some pages here in our notes. We have sine of x over 2. Well, if you have sine of x over 2, here it is. You can put into your expression 1 minus cosine over 2. 1 minus cosine. What about the plus minus? We'll get to that in a second, okay? 1 minus cosine over 2. So I'm going to put 2, and then I'm going to put square root of 1 minus cosine over 2. And then I can put it again for sine of x over 2. Once again, don't worry about the plus minus. We'll get to that in just a second. Don't worry about it. And then 1 minus cosine x all over 2. And of course, again, we'll talk about the plus minus in just a second. And then bring down your positive cosine x. So positive cosine x. Now, look, students, either this radical is positive or it's negative. And if it's positive, then this one's positive too, because you're dealing with the exact same sine of an angle, sine of an angle. So either we have a positive here and a positive here. There's no way we'll have a positive here and a negative over here. That's not going to happen because we're dealing with the same function, sine of an angle, sine of an angle. So either we have a positive and a positive, which when you multiply a positive times a positive, you get a positive anyways, or we have a negative and a negative, which in that case, a negative times a negative is still a positive. So it really doesn't matter what sign you use. You're going to multiply them together anyways, and a positive times a positive is a positive, and a negative times a negative is a positive. So it really doesn't matter. So now remember what I taught you. I don't care if you have the square root of 5,280 times the square root of 5,280. Your answer is just 5,280. Anytime you take identical square roots and multiply them together, you get out the radicand, the number on the inside. So it's the same thing here. I'm going to go ahead and multiply these together first. I'm going to bring down my 2. So bring down your 2 and then put a big parentheses. And now let's multiply these together. Well, the square root of this times the square root of this is just 1 minus cosine x over 2. And then plus cosine x. Now, this 2 is being multiplied times this parentheses. So I think it would be extremely intelligent to get a hold of the 2 and bring it up with, I think it'd be wise to put the 2 over 1. So I have 2 over 1 times 1 minus cosine x over 2. Oh, look at this. 2's cancel. Sweet. So I have For my numerator, I have 1 times 1 minus cosine x. Well, 1 times anything is just itself, so 1 times 1 minus cosine x is 1 minus cosine x. And then, of course, for the denominator, 1 times 1 is 1. Do I really have to put that? No, I don't want to do that. Just 1 minus cosine x. And then bring down your positive cosine x. Look at this. Are we not looking good? You have a negative cosine x and a positive cosine x. They cancel each other out, and you're left with just 1. And that's what you wanted. We wanted to take this whole expression and break it down and simplify it until we came up with 1, and we did it. So there we go. Now for the bad news, review sheet time. Usual amount, 40-some problems, 43. Yes, my voice cracked. Page 554, all of these. Page 488, 530, 531, 592. Now look, divide it up. You have 22 problems on one day, 21 problems on another day. Mr. Earhart, that stinks. Okay, fine. Then out of these 22 problems today, what's a normal homework assignment? 15? 12? Let's say 12. So do 12 problems today. That leaves you with 10. So now you've got 10, 20, you got 31 problems left. Now tomorrow, Friday, you know I don't give you a video. All that I give you is a video with the review sheet worked out, right? There's no notes. So technically, you should be able to do about twice as much homework. That's true. You really should. I mean, if I'm not giving you notes to take, that means you can spend the same time you would use in class plus your homework time. So if a normal homework assignment is 12, on Friday you should be able to get 24 problems done. So now we have 31 problems left, 21 plus 10. On Thursday, today, you're going to do 10. You're going to do 12. That leaves you with 31. Then on Friday, you're going to do 24. That leaves you with 7. And anyone can do 7 problems over the weekend. Do 3 on Saturday and 3 on Sunday and have 1 left over or something like that. Okay? So I'm telling you guys, this is really not a whole lot worse than a normal day of homework because tomorrow I don't give you anything new. You have the whole class hour. If I was at Tennessee Temple or Berean Academy, the students would have an hour to sit there and work on the review sheet and then go home and work on it a little longer. So you have that same option. So here's your review sheet. Write it down. The review sheet you want to look for tomorrow, and actually I want to get this name right, so hold on one second. The video you want to look for tomorrow, let's see if we can't find it here real quick. Where's some of the review sheets I've done? Hold on one second. Here it is. Okay, so I put the date and then the review sheet. Okay, so the video is going to be this. The video you want to look up tomorrow to help you do the review sheet will be pre-cal, October 4 review sheet. Got it? So that's the video you want to watch on Friday, and that will help you do the review sheet. If you have any questions, call me, email me. I'm here to help you. Have a good rest of the day, and we will see you on Monday. Be sure and watch the help video on Friday.